Hello, everybody, again. Like Chris got said, my name is Fanis Prodromou. This is my card. Let me introduce myself. I'm a Google developer expert for Angular, senior Angular developer at the company ASI, co-organizer of the Angular Athens meetup here in Greece, and an Angular content creator. And I really like the Angular Love blogspot where I spend and write my articles there. So today's talk is about Angular signals, and we will have a look under the hood and beyond. And I would like to start with this kind of thing. Angular signals is the new reactivity system. But you already know that, right? That improves. So let's see what kind of improvements we have. Improvements into the developer experience, user experience, and performance. Let's now see a bit more details about every pillar. On the developer experience, we have a bunch of new APIs to use already. And these are the signal inputs, model input, signal queries, the effect. After render effect, I really like that. And I have a very cool article into the Angular Love. You can go there and check it out. Commuted, linked signal, and the resource API. And into this talk, we will mainly focus into the linked signal and resource API. And we also have improvements into the user experience. And I know that you might be thinking, how come a framework changes something into the user experience? Well, this is happening not directly, but I can say indirectly, let's say. And we have improvements into the user experience because we have now more fine-grained change detection. And this leads to have a glitch-free rendering, which of course improves the user experience. And now how about the performance? With signals, we can run a zoneless application. Don't get me wrong, Zone.js is amazing, is magic, or used to be amazing. But what it does is that we have Zone.js here, and we also have the change detection system, but it triggers that many times the change detection. And of course, this is not that great. And we need to keep, of course, the change detection mechanism, but with another way. And since we have now signals, we have more fine-grained change detection, which leads to have fewer change detection cycles, which means that we have better performance. And now I would like to focus into this component tree. We have components from 1, 2, 3, 4, up to component 13. And as you can see into the component 2 and component 30, I have this kind of -5, which is just a counter that will be increased every time we click the component 13. And I would like to observe 3 different things. What would be the behavior of our application if we have a default change detection and observable, and on push change detection and observable, and then on push change detection, but this time using signals. Let's start with the very first one. And as you can see, whenever we're clicking the component 13, we have a new color on every component. New color means new change detection. And you can imagine that would be, this is not that nice, especially for enterprise applications. But of course, we can solve that. And we already know how to solve this, and we can use on push. And this time, what we can see is that we're clicking the component 13, and only the ancestors of that component are marked as dirty and change detected, which is much better, but still, why do we have to change detect the components, the ancestors of that component, since we do not have something there to re-render? And then we have the signals, where, as you can see, whenever I'm clicking the component 13, we are change detect only the component 13 and component 2, because we have something to re-render. And of course, this is much, much better in terms of performance. But how are we achieving that? Behind the scenes, there is a graph. So let's say that we would like now to create a very small producer, a producer that produces something for us, produces a value. Const counter equals signal with a default value of 0. Nice. So this corresponds to the very first bullet point into our graph. So we'll have this there, and now it's time to consume this one. So how can we consume? Well, what we can do is into our HTML, we'll have the counter, and we're using the parentheses. The parentheses there is magic. What it does apply a logic. It applies a connection between the producer and the consumer. Give me just a sec. And now the producer is aware of the consumer, the producer is aware of the consumer is aware of the producer. And this thing is amazing because now, if for any reason the consumer goes out of scope or being garbage collected, we do not have to go there and explicitly kill this kind of connection, which means that we do not have any memory leak. This will happen automatically for us. And the graph will continue to grow for as many signals we use, even with a commuted, or like I said, the graph will continue to grow. And now we have a more fine-grained change detection, and Angular knows how the data flows, which is an amazing one. And someone would say, is this how we have that great performance? Well, yes and no. We also have the so-called pull-push, which is an amazing algorithm, and I will show you how this actually works. Let's assume that we will have two different signals. We have the first one, which is const is valid signal true, and we have the second one, which is signal Fanis. Okay? Into an effect, we would like to have a condition and check if this valid equals to true. If this is true, then we would like to console log the username. No more than that, a simple thing. But please note that into the effect, we have two different signals. And now, what I would like to do is to observe what would happen if we change the is valid from true to false, and then the username from Fanis to Fanis2. So let's do that in action. On the right side, we can see the producers, and on the left side, we can see the consumers. Now, let's change the is valid from true to false. And whenever we're doing that, what is great with this one is that the producer sends a push notification, just a notification, not the actual value, just a notification, like a poke. Something like, hey, dude, you know what? Something got changed in my side. Okay, so the consumer received the notification. And now let's do the same thing with the username. We change the value from Fanis to Fanis2, and we do the same thing. We send a push notification, just a push notification, not the value. And now it's time to go into the effect and check the actual value. And you know what? We know that the is valid knows that it has a value because previously received a notification, and goes there and pulls the value and checks that, and the value is false, which means that we can terminate the condition. And the username will never be executed in this condition, and that's why we're saying that the signals are lazy, will be evaluated when they have to be evaluated. So let's now continue this one and see another example. Into the effect, I have the console log and I have the is valid and username, two things into the same console log. And let's do now the same thing, but before we continue, the console log here will run only once, only once. If we think that for a while, using an RxJS semantics, we will think that the console log will run 2 times. But how come now it runs only once? Let's see. We have the is valid and we're doing the same thing. The producer sends a push notification to the effect, just a notification, no more than that. And now it's time the username to do the same thing. It changes a push notification to the effect that something got changed. And now it's time to run the effect. And the effect knows that it has to go there and pull both values. But how come it manages to run only once? If you remember, previously we discussed about a graph. And behind the scenes, of course, we have a graph, and the graph has 2 different dependencies. We have the dependency of is valid and the username. And Angular knows, since we have a more fine-grained flow and knows how the data flows, it knows that we have to go into the is valid, we have to go into the username, pick the values, evaluate, and run actually the console log. And I know that the way that signals work behind the scenes are magic. And I know that you might be thinking, can I have the same magic in HTTP calls? And the answer is yes, but I have first 3 questions for you. Let's start with the very first one, which is a very simple one, okay? How would you handle the situation where you would like to display a loading indicator, just a loading indicator into your UI. How can you do that? Well, you can do that imperatively by having just a flag and switch that flag from true to false, something like that. Or sooner or later, you will realize that this is not that dry approach and you prefer to have something more dry and reusable, and you will go to use something like a custom RxJS operator. And sooner or later, what you have to do is to use this custom RxJS operator every time you use a service, especially whenever you have to have an interaction with HTTP. And please note that this is more like a pseudocode. I'm just sharing an idea. And then what you can do with this kind of thing, perhaps you can have if loading state dot is loading, something like that. Okay, so this is the first question. Let's go to the second question. How about now, if you have a failure response from the HTTP and you would like, of course, to inform the user that something went wrong, how can you do that? Same thing, you can go and do that imperatively by holding a flag has error from false, mark that to true, something like that. But of course, sooner or later, same story, you realize that this is not a dry and you would prefer to make that more declarative. And you can utilize the same custom RxJS operator. And of course, you can use that into your services. Awesome. And how can you use that into your UI? If loading state dot has error. Amazing. And this works just great. But this is a tailor-made solution, all right? Tailor-made solution, which means that someone from your team, a newcomer to your team, sooner or later will have this kind of compilation error, and the newcomer will realize, oh yeah, I have to ask someone else to instruct me of how to do that. And the third question is the following. How about if you're going to have reactive HTTP calls, dynamic HTTP calls? And what I mean with this is the following. Let's assume that you have no more like a type ahead component. And the input feed could be bound with a signal string or like a form control or whatever. And what I would like to do is that whenever we are typing, whenever we have a keystroke, would like to invoke some HTTP calls. And in this case, I have P, I, Z, and I have 3 different HTTP calls. And someone could say, wait a minute, wouldn't it be better here to cancel the 2 previous HTTP calls? Yes, that would be great, and we'll see that in a second. But before we go there, how can we achieve that with signals? Someone would ask, can we do that using an effect? Well, no. And the reason is that signals are designed to handle a synchronous state, not a asynchronous state. It's managed to handle synchronous one. And the effect, same thing, is not designed to handle a synchronous state and can have unexpected behavior. Let me give you an example. Let's assume that we would like to make a request at time 0 and at time 1. At time 0, we are requesting for triangle, and that response will last something for 500 milliseconds. Nice. In between, the user changed their mind and now would like to request circle instead of triangle. And sometimes the HTTP response in terms of time is unpredictable, and that response will last only for 100 milliseconds. And of course, the user will get back a nice circle, which is amazing. This is, after all, what the user requested, right? But after a period of time, the user will get back the previous one, the unfinished HTTP call, which is the triangle. And that would be the undesired state, and this is a wrong thing to have. So we have the synchronous state, which is from one side, which we have from the signals, and on the other side, we have the asynchronous, which is the HTTP call. And we need now somehow to bridge them together. How can we achieve that? How about if we grab the HTTP, which is the asynchronous one, and create a structure that will always have something for us, will always have values. And what I mean, this kind of structure could be the is loading, could be the error, and the error could be null undefined or the actual HTTP error response, and data where eventually can have the response from HTTP. If we have a structure like that, and especially if we convert them to signals so that they contribute to the signal graph that we saw previously, that would be amazing. And let's now talk about the HTTP resource. the HTTP resource makes a reactive HTTP request and exposes the request status, the thing that we saw previously. We have the loading, we have the error, and the response value. We have the data that we saw previously. And the HTTP resource accepts two different arguments. The first one could be string, object, or a function, and the second one can be options. So let's start with the very first thing to see how to use that using a string. We have the HTTP resource, you're using the template literals, and then here we have the signal value, which is a dependency. Like what Matt said previously, whenever the signal value has something new for us, whenever this is marked as dirty, a new HTTP call will be invoked. Nice. So this is how to use the string. Now let's see how to use the object. And as you can see, into the very first property, we have the URL, and I'm using the exact same URL that I had previously. And again, the signal value here is a dependency. But not only the path parameters are dependencies, the query parameters are dependencies as well. Which means that if we have any value there, a new HTTP call will be invoked. And now let's see this one, which is very interesting. And before we go there, let me just highlight that the HTTP resource is designed to fetch data, not to mutate data. It's not designed to delete, update, or create. It's designed to fetch data. And you might be asking now, and why do we have there the method? Don't we have to have it always get? Well, no. There are plenty of endpoints out there that they require to have the post as a method to fetch some data. These are something that some companies decided to have for valid reasons, but the Angular team from their side decided to be as flexible as they can be regarding the API of the HTTP resource so that they can accumulate and handle different cases. And now let's see the third one, which is the function. But wait a minute. This one seems similar to the string. The only difference here is that we have this kind of arrow function. Why is this a difference? Using an arrow function, it means that we can also have a condition, and if we return undefined, we won't invoke any HTTP call. So this is how to use string, object, and function. And now let's see how to use the options. One of the options is the default value, which will be appear into the UI whenever we have an error response, a loading response, or the HTTP resource. Actually, the HTTP is idle. And we can also have the parse, and I really like this one. We can even use Zod schema, which means that we can make sure that the incoming payload should match the defined schema that we have defined from our UI. If they do not match, we will throw an error. Okay, how can I use that? Well, what I'm doing here into the upper code, we have a resource, you name that, you define how to name this kind of variable, equals HTTP resource. And then into your HTML, you can have if resource.isLoading. Please note that this is a signal. As soon as this is true, we have the loading indicator. If resource.error, if this is error, you handle the error. And eventually, of course, we have the value. And you can do something with the value. And the great thing about that is, since they are signals, we can even create a derived state from the incoming value. Okay, so let's try now to answer the questions. Are we done with the loading? Yes, we saw that we have the loading indicator, we have the error handling, and we also are handling correctly the data. But for the last part, I feel that there are some unanswered questions. How can I cancel the previous HTTP calls? And the answer is that the HTTP resource behaves similar to switch map, which means that it cancels the previous unfinished HTTP calls. And how can I debounce the calls? Well, we should debounce the value and not the calls. Unfortunately, we do not have that much time here to go into much details of how to do that. I have a video into my YouTube channel, Code Shots with Fanis, where I'm diving deeper into the HTTP resource and explaining how to debounce the value. Okay, so it seems that we are done with the developer experience. This is much better performance. We have improvement there, and the user experience as well. Awesome. So can we have something more magic? And yeah, we can have the linked signal. And that would be the last one that I would like to present to you today. And I would like to start with a very small example. We have the list of items, which is signal, and we have their item 1, item 2, and item 3. Nice. And then we're using the linked signal where we can derive the count of items from a given source. And now the count of items, of course, will return 3, because this is the length of the source, which is the list of items. And the linked signal returns a writable signal, which means that we can even use the method set to change the value. Someone would say here, you know what, this seems similar to computed, and you are right. The difference here is that the computed returns a non-writable signal compared to linked signal, which returns a writable. Look at a minute. Is this the only difference that we have non-writable and writable? No. So let's focus a bit more into another notation of linked signal, where what we can see here is that, again, the count of items derives from the list of items, which is our source. As you can see also in line 4, this is our source. And the great thing with this one is that the count of items is now linked with the list of items. And why is this important to have them linked? Think the following, that for any reason we would like now to extend the list of items, which is our source. We have item 1, item 2, item 3, and we would like now to add item 4. At the time that we are changing that, the computation function will be automatically invoked, and the length, of course, will become 4. So this is a short introduction of the linked signal, and now let me give you a very easy to digest example. Let's assume that we have a drop-down. We have the selected item, and below that, on the right side, we have the selected item is null. We didn't select anything. We're expanding that, and we can see that we have item 1, item 2, and item 3, and still the selected item is null because we didn't select anything yet. Now we are selecting an item, and we can see that we have this kind of nice green background, and we also have the interpolation, which says the selected item is name item 1. Nice, simple thing. And what we have behind the scenes is that we have this list of items, which is a signal, name item 1, name item 2, and name item 3, and the selected item, which is bound with our dropdown. And for the sake of this presentation, I have the list of items with the very first item of this kind of array. And I noticed that I have a typo there. We need a parenthesis. I will fix that later. And let's now think the following. We have the list of items, and now we have an HTTP where we are subscribing. We are making an HTTP call. We get some new items, and we would like these new items to set them into the list of items. What will happen? Well, the problem with this is that the selected item will appear into the interpolation because we didn't clear that imperatively. But the actual selected item is not there because we destroyed the object reference. And this is something that we know when we have to deal with a dropdown is a pain, and we have to find workarounds. So to picture a bit, the problem is that the list of items and the selected item, they are not linked together. And the solution, you know what the solution would be? The solution is very easy. In this case, we have to link them together, and we have to use the linked signal. And if we do that, the selected item will be linked with the source, which is the list of items. And whenever we have something new into our source, the computation function will be invoked, and the selected item will always have the correct value, either being the selected item, meaning item 1, item 2, or item 3, or null. So having the linked signal, I feel that the developer experience has been improved a lot. And that goes from my side. Thank you a lot for your time and your attention.
Okay, thank you, Fanis. Like, whoa, that was amazing. So much knowledge packed into like, what, 30 minutes? That's really impressive.
Thank you.
Yeah, so now it's time for our Q&A session. So be sure to ask your questions in the chat, and let me have a look here. Okay, we have one. What is the difference between the computed and linked signal? Are there any specific use cases to use computed versus linked signal?
This is one of the things that I try to highlight into my presentation. The computed returns a non-writable signal, whereas the linked signal returns a writable signal. But this is, let's say, the small difference between them. The linked signal, and like what the name implies, is that you are creating a connection. You are creating a connection with your source. And since we have the commutation function, that commutation function will be invoked. And are there any specific use cases? The drop-down that I presented previously is a use case is to digest and use it even into your production system. I hope that answers the question.
Yep, I think so. So let me take a look if there is another one. Okay, seems not. It seems like there is no more questions. So it was so clear, so packed with the knowledge that it seems everything is quite clear. So again, thank you, Fanis, for a great presentation. Thank you for being with us. And I hope to see you at future events.
Definitely. Thanks a lot for having me. It was a great one. And yeah, thanks a lot.